When adding and subtracting polynomials, I have two different methods to show you. The first method is just like combining like terms. You're going to identify variables raised to the same exponent and simply add or subtract the coefficients of those variables. So in this case, I have a b cubed term, and it can be added to this other b cubed term in the second polynomial. So 2b to the third power plus 3b to the third power is 5b to the third power. Your next set of like terms are positive b squared and negative 9b squared. So this has a coefficient of 1, so treat it as 1 minus 9 to get you negative 8b squared. And then the only other part of our polynomial that we have left is this subtract 4b, but it has no other term like it in the second polynomial, so you just leave it as subtract 4b. So our final sum is 5b to the third power minus 8b squared minus 4b. Now if your problem has a subtraction sign between your two polynomials, what you're going to do is you're going to change the sign of every term of that second polynomial, just so that you make sure that you are subtracting every quantity. So in this case, we would keep our same first polynomial, so 3x squared plus 9x plus 8. And then we're going to make sure we subtract every single one of those terms. So I'm going to say plus, but then distribute that subtraction sign, so it's a negative 5x squared, and then a subtract 12x, then an add 4. Now we can combine all of our like terms. Here's my x squared, and that matches with this negative 5x squared. So then 3 minus 5 is negative 2x squared. My positive 9x matches with my subtract 12x. So 9 minus 12 is negative 3x. And my last pairing is this positive 8 for my constant in the first one, and my positive 4 is my second constant, so that makes a positive 12. So then the difference between these two polynomials is negative 2x squared minus 3x plus 12. Now the other method that I like to use is called stacking. You're simply going to line up the first polynomial and the second polynomial as far as matching terms, just like a regular addition or subtraction problem that you're used to seeing. So I'm going to rewrite my first polynomial, 2x squared plus 19x minus 4. And then I'm going to match the second polynomial with the first polynomial. So my 3x squared will go underneath my 2x squared. My subtract 10x will go underneath this add 19x. And then my plus 6 will go underneath that subtract 4. Now again, combine your like terms, just like a regular addition or subtraction problem. So I have 2x squared and 3x squared. That makes 5x squared. And then I have positive 19x and negative 10x. So 19 minus 10 is 9, and that's a positive 9, so I'm going to say plus 9x. And then I have negative 4 plus 6 will be a positive 2. And then my last example I have for you has 3 polynomials, and that's where the stacking method comes in quite nicely, so then you can rearrange everything that you have and find those like terms if it gets kind of messy. Some of us like to save space as well so that it's nice and tight. Again, write your first polynomial, 9x to the third power. I'm going to skip a little space in here because I don't have an x to the second power, so I'm going to write plus 3x minus 13. Now our second polynomial here, if you'll notice, it says subtract, so that means I'm going to use the opposite signs that I have in here. So it's going to be a negative 6x squared. I'm going to write that here in my descending order of exponents. And then instead of subtract 5x, I'm going to say add 5x. And then my last polynomial here has an addition sign in front of it, so you keep the signs of all of those. So it's a positive 2x to the third power. I'm going to write that directly underneath my x to the third power. So 2x to the third power. and then keep this subtract x squared. I have another subtract 8x, and then plus 4. If you notice, in each column I have the same exponents and variables. So I've stacked all of my like terms. Now just add or subtract like a regular addition or subtraction problem. It's positive 9x cubed and positive 2x cubed, so that's 11x cubed. Negative 6x squared, and this has a coefficient of 1. If it's not written, it's a 1. So negative 6 minus 1 is negative 7x squared. And then I have positive 3, positive 5, so that makes 8. But then subtract 8 gets me nothing, so I'm not going to write anything down there. And then I have negative 13 plus 4. Okay, so that is going to be a negative 9. And there is my final answer. Once I have added and subtracted my polynomials, I'll have 11x cubed minus 7x squared minus 9 as my final answer.